So here you go. We are into the next board. And what is happening here, guys? First thing first, we just talked about most of the time that the BGP neighborship, uh, whatever we have talked till now, BGP neighborship between these two routers should be can be formed when we have these two routers directly connected with each other, right? So we have seen that R1 and R2 were there. We were running a subnet here. We are configuring this is a 12.1, this is 12.2. And when we put these commands, router BGP something, and the neighbor command, everything is coming up. The neighborship was coming up. But here is my point that can it always be the case that these two guys are going to be connected? Because in IGP, this is the must condition. In OSPF, in EIGRP, in RIP, if you want to have neighborship between these two devices are connected directly over a link. Otherwise, no neighborship. It's as simple as that. But BGP does not have BGP doesn't have that kind of requirement. Why? Because that might be certain situation in which you want to run eBGP or external BGP, which is not directly connected, right? So till now, whatever we have discussed, guys, in terms of neighborship, that is eBGP, Exterior Border Gateway Protocol. Why? Because the autonomous system numbers on both the side of the neighborships are different. If these numbers are different, we are talking about eBGP. If these numbers are same, then we are inside a particular autonomous system. Then basically we are talking about IBGPs. But IBGP we are going to learn from tomorrow. Today and yesterday was more on, today is going to be more on eBGP. It is as simple as that. So what is the situation where you are going to see that, yes, you want to make eBGP, but the endpoints are not directly connected. Suppose between R1 and R2, the topology is same, that you have two autonomous system number AS100, AS200, two routers R1 and R2, and now we have loopback interface also on R1, which is 1.1.1.1/32, on R2 2.2.2./32, and basically routing is not a problem. If you do a ping on R1 towards 2.2.2.2, it is going to ping it. If you ping 1.1.1.1 from 2.2.2.2, it is going to ping. It is as simple as that, right? So by the way, guys, you can specify the source interface also when you do a ping. So ping 2.2.2.2 using source 1.1.1.1, it is going to give you the result that it is pinging. So I have created the network maybe through static routes, right? So ping is not a problem here. Everything is working fine from here to here, right? But I just want to make sure that you understand that if I do not specify the source, then the source address is going to be the interface IP address from which this packet is coming out. It is not going to be the 1.1.1.1, guys. Maybe the packet is coming out from this interface, and if you have configured any IP address on this interface, the source of this ping message is going to be this one. This is again interesting thing, right? So you need to deliberately write the source address if you want to ping from 1.1.1.1 to 2.2.2.2. Otherwise, it is going to take the IP address of the exiting interface and not this 1.1.1.1. It is as simple as that. Now, here is the thing. Between R1 and R2, we have three different physical links, and we have configured three different IP subnet over it. If that is the case, two things can happen. You can run three BGP connections between R1 and R2 over each and every interface. That is not going to create any problem, right? Because you can do that. But why do we need three BGP connections because the information you are forming from here to here is exactly the same over all these three BGP connections. You can say one reason could be the redundancy, but it can be achieved in other ways also, right? So it is pretty imperative here that you do not want to run three BGP connections. Uh, can there be any solution? Yes, you run BGP between these two loopbacks instead of running the BGP between these physical interface. Run this using these loopback. And if that is the case, if you want to run the BGP neighborship between the loopbacks, these loopbacks are not directly connected. It is as simple as that, right? How you can know that the particular link is directly connected or not? But definitely means if you have 12.1 here, 12.2 here, and if you know that the network between them is 192.168.12.0/24, you know that there are going to be 255 hosts, 0 to 255 on this network, and 12.1, which is IAM, 12.2 is something which is part of my network. So I can say that basically these two are on the same link. It is as simple as that. But here if you see 1.1.1.1 and 2.2.2.2, they are not on the same network. They are not directly connected. And till now, in case of external BGP, we talked about only neighborship across a directly connected link. This is not the case here. So can't we make the neighborship? Absolutely we can. So what we are doing here is we are running router BGP 100 command on router R1. I have written this command which is very simple, neighbor 2.2.2.2, which is right here, right? Remote AS 200, of course the orange AS number is 200, no problems with respect to that. And what I'm writing here, neighbor 2.2.2.2. Now I do not want to make neighborship with this physical interface IP address, right? If I do not do that, then the source of my BGP packets are going to be interface IP address, which is 0/1, 0/2, or 0/3. I do not know about it. I do not want that, right? What I want the source of these packets should be 1.1.1.1, and that is why I have specifically mentioned this in my BGP that neighbor 2.2.2.2, the update source is going to be loopback 1. And what is the loopback address? The loopback address is 1.1.1.1. And that is why now the BGP packets, whatever is coming out from this R1, is going to have the source IP address of 1.1.1.1 and destination IP address of 2.2.2.2. And of course, the port also at the TCP layer. It's simple. Similarly, what I'm doing is I'm doing the same thing here. Router BGP 200, neighbor this, and the neighbor this command. 1.1.1 update source is going to be loopback 1, which is actually setting it the source address, which is going to be 2.2.2.2. It is as simple as that, right? From now on, guys, you will get somewhat whatever I'm going to tell you in upcoming boards, which might challenge your current knowledge, right? And you can argue with me. You can just have a debate with me, because it happens when you have learned something for so long, right? And when somebody comes and challenge it, that no, that information whatever you learned from last 5 6 years, it it is actually not that correct, right? Then you come into the argue mode, and that can happen in today's class, because I will challenge whatever you have learned now till now in the BGP neighborship. And it might be that maybe I am wrong here, right? But it should need a discussion. So if anything comes to your mind after seeing the next one or two boards, please do ask your questions, right? So guys, what is happening here is I have mentioned these commands here on R1, these commands here on R2, but still when I do show IPBGP summary, I do not see a number Under this column, I see a state which is idle. It means that the BGP neighborship is not there. This is the first state of the BGP neighborship. You all know about it, right? Simple. BGP is just not coming up. So what I'll do is I will request you to raise your hands, everybody who knows the answer for it, that why at the first place this BGP neighborship is not up and running. Anybody? But first raise your hand. Okay, I could see that the Kamal has raised the hand and Prashant has raised the hand, Burak has raised the hand. Anybody else who would like to contribute? Balakrishna, okay, I could see Balakrishna also. Okay, four are enough, right? To just take a gist of what you know. So if I go to Mr. Prashant Patil ji, please tell me why this neighborship is not coming up.
Because of this TTL value, uh, we are using BGP, eBGP connection, and it is setting TTL value 1 here.
Okay.
So we need to use multi-hop.
Okay, so Prashant ji is saying that actually the TTL value is the problem. TTL of 1 is the problem. Okay, this is interesting. What about you, Mr. Kamal? What do you say?
Same answer. By
Same.
default, BGP assumes neighbor is one hop away.
Okay. Okay. What about you, Mr. Bala?
Yeah, the same. Yes, the same answer, Vishnu. So it is not considered as it is TTL is going to be one for ABGP packets, and the loopback is not considered as directly connected in this case.
Perfect. 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 And then basically, if I ask Mr. Burak, what's your answer?
Okay, Vishnu, I think router 1 and router 2 doesn't know how to reach each other's loopback IP
They
addresses.
know. I have made sure that the routing is there.
Okay.
So basically, okay. So I would say Prashant, Balakrishna, and Kamal have the same answer, right, guys? Your answer is absolutely correct that eBGP multi-hop can solve this problem, right? Because it can increase the TTL value. But your answer is correct because if you configure eBGP multi-hop here right now, the BGP neighborship is going to be up and running. But still, I do not agree with your question, with your answer, right? Maybe it needs a little bit more discussion, and that is what I'm going to do on the next board. Okay, everybody is saying here that TTL is equal to 1 if you do the by default, whenever you make the BGP neighborship, whatever the packets coming out from here are having TTL is equal to 1, and that TTL is going to expire when you reach here, right? And that is why uh, 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 basically this BGP neighborship is not coming up. But let's see what exactly happening, right? I do agree with you, right? And that is why I mention here, is TTL is culprit here? Is it actually culprit here? Because when I do that Wireshark, when I capture the Wireshark, it is indeed the time to live value was 1, right? So what is happening, guys? Irrespective of the fact whether it's a TCP SYN message or basically the open message, whatever is generating by this BGP process here, right? This message was having TTL value of 1, but this message was generated by this router itself. This message is going with the TTL value of 1. Of course, the source and destination, 1.1.1.1 is the source, destination is 2.2.2.2. So there is no doubt about it. So we all agree, and you are absolutely correct, that because now these are not the directly connected neighbor, but still you are sending the TTL value of 1. But try to understand, guys, this TTL value 1 or this complete IP packet with this value is reaching right here. It has reached here, right? It is not going to send to anybody outside R2. Suppose if you're making neighborship between R1 and R3 with this packet, definitely you are right. Definitely, Mr. Kamal, Mr. Bala, you are absolutely right, Mr. Prashant, that if the packet comes with a TTL value of 1 here, and it is going to send into its routing table, and if it wants to send it outside of this router, no, it cannot send it because the TTL value becomes just 0, and if it is 0, it cannot be go out. But now try to understand. We are on R2. We have got this packet, right? This packet is right here, and this is the loopback interface which is directly connected to this router. We are not sending it out. This packet is inside this. We can what we can do is we can give it to the BGP process, and BGP process can make the neighborship, right? Because at the end of the day, my whole sole intent was to send this SGP message from router 1 to R2, and R2 got it. But yes, I am absolutely sure, I am with you that this packet, BGP packet, is not going to go out, whether it's a TCP or whether it's an open message or any message. Because at the end of the day, you all know that the BGP messages are going to be encapsulated in IP, and this IP is going to be the TTL value of 1 by default. So by default, BGP take TTL value of 1. You can see this in Wireshark capture right here. Right here, guys. You can see that. Right? But the packet has reached to R2, and that is what I wanted. I totally agree. I'm again and again repeating, it is not going over R3 for sure. But it has reached to R2. But still the question is same. If that is the case, then Mr. Vishnu, why neighborship is not coming up? We can agree, you can agree with me. Whatever I am saying is correct. The packet is reached here. But if I am correct, that the neighborship should come up with only these two commands. Means I need to specify neighbor 2.2.2.2 remote AS200 and neighbor 2.2.2.2 update source loopback 1. These commands should be absolutely enough to form a BGP neighborship. And believe me, guys, these two commands would have been enough if BGP do not have a specific condition check, right? What BGP does by default. So by default, BGP does two things whenever it is forming eBGP neighborship. The first thing is it is going to say whatever the messages I'm sending you, it is going to have TTL value of 1. You all know about it. The second thing is done. What BGP does is it checks that whether these two, wherever I'm going to make a neighborship, right? Whether these two are directly connected or not. And this is known as directly connected check. If by default it is doing this, by default it is checking whether the two peers are directly connected or not. If they are not, BGP is not letting them to form the neighborship. TTL value is equal to 1, you just saw right here. But right, the second test which BGP does is it checks whether these two peers are directly connected or not. In this case, these are not directly connected, and that is the reason this neighborship was not coming up. It is as simple as that. TTL was not the reason. And I'll prove you that why eBGP multi-hop was resolving this problem, right? If this was not a TTL problem, then why eBGP multi-hop was solving a problem? I will let you know. But I also want to showcase you that if you by any means, if you just remove this check, what check? Directly connected check, right? If you can if you can say the BGP process of R1 that by default you do two things, TTL equal to 1 and directly connected check, you please do not do directly connected check for this neighborship at least. And interestingly, we can define that. And that is what we are going to do in the next board. We are going to say we are going into the routing process of R1, the BGP process of R1, and we will say BGP, do not check for the directly connected neighbor. Please remove that check. And that is what I'm doing here. If you see here, what I've done is I have included one more command right here. This command was there, command number 1. Command number 2 was already there. If I talk about this command number 3, this I just introduced that while that Mr. BGP, while making connection with 2.2.2.2, you please disable the connected check. Now BGP is not going to check whether these two guys are connected or not, but it is going to give you, it is going to generate the TTL value still as 1. It is as simple as that, right? Similarly, I have introduced this command here and specifically written here, disable connected check. And if you do that, even without using eBGP multi-hop, your neighborship is going to come up with this TTL is equal to 1. Interesting, right? It means TTL was not a problem because the packet was anyhow reached to R2. And I'm not saying that you need to send it to any other router. If you do not want to, the packet has been reached here. As simple as that. And that is why you are seeing a prefix number here instead of any state. Interesting. But what is happening with eBGP multi-hop? Let's see that. Okay. So I think you know the fact here that TTL was not the culprit, guys. Here the culprit was the BGP check. BGP actually checks whether these neighbors are directly connected or not in case of eBGP. If you get the number, autonomous system number, if you are making a neighborship with a autonomous system number which is not equal to you, it means that you are making eBGP neighborship, and during this eBGP neighborship, BGP has a check that whether these two guys are directly connected or not. If these two guys are directly connected, then let them make the neighborship, otherwise not. As simple as that. And that is what we have disabled from disable connected check command. Right? But now let's try to understand there is another option through which you can solve this problem. Even if you do not use this disable connected check, then still you can use another command to make the neighborship up and running. And that is what I'm doing here. That is exactly what I'm doing here is. So you can see the same situation. If you want to make the BGP neighborship between 1.1.1 to 2.2.2, that is why we have these two commands here, update source. And now what I have written is eBGP multi-hop. Believe me, I didn't write 255. I just put enter there. 255 is the default value which is taken by eBGP multi-hop. Similarly here, what is the meaning of this command now? The meaning of this command now is whatever the number you specify, maybe 2, 3, 255, all the BGP messages, whether it's a TCP, open or anything, you know that those are going to be encapsulated in the IP. What are the BGP message you have? And in that IP, you are going to have the destination, which is 2.2.2.2, source 1.1.1.1, and you are going to have the TTL value. But now you are saying whenever Mr. BGP of R1, whenever you generate this BGP messages, which are encapsulated in IP, just make sure you mark them with 255 or whatever the value you give. Means if you are giving here 3, it is going to mark it as 3. It is as simple as that. And then send the packet here. And the neighborship will come up. But here is my problem. Because I just explained, TTL was not a problem. If it was only 1, the message would have reached here, right? And it was reaching here. You just disable the connected check and it was coming up. But what is happening now is that you have just mentioned the BGP multi-hop command and it is solving the problem. So guys, believe me, this multi-hop command of BGP does two things, right? Two separate things. What are these? Number one, it says send BGP message out of the R1 if you have enabled it on R1 with the TTL value, whatever you specify. Here I am specifying 255. That is why 255 was coming out. If I specified here 2, then of course this value would have become only 2. It is as simple as that, right? But now let's talk about what is the second thing it is doing. The second thing multi-hop command was doing is it was disabling the directly connected check done by BGP. So only with this one command you are doing two things. You are disabling the connected check and you are increasing the TTL value. So now in this case, if we have router R3 also, you should be successfully able to make the BGP neighborship between R1 and R2 because now you have disabled the connected check and only with one command you are doing all these things, right? With multi-hop command, you are disabling the correct connected check and you are increasing the TTL value. If that is the case, then here the TTL value will be 254. Here the TTL value will be 253 and the packet is not going to be dropped. It is as simple as that, right? So this is the whole soul thing behind multi-hop. It was not doing a single thing, it was doing two things, right? And if you do now show IPBGP summary, you are going to see that state prefix is 0. It means that everything is up and running also. And by the way, we haven't configured specifically the disabled connected check because we know if you run EBGP multi-hop command with more than one value, it is going to disable the connected check on its own. It is as simple as that, right? So let's move to the next board because I wanted to showcase you in the Wireshark that basically if you are doing this, if you are using EBGP multi-hop command with value 255, I am seeing a BGP message here which is encapsulated into internet right here, and you can see the time to live value is 255 here. It is as simple as that. So I hope you got all these concepts because most of the people when they go for the interview, they have been asked questions around it. So I think you have a good basic understanding of how EBGP multi-hop and disable connected check work. So I deliberately didn't tell you regarding there is one more concept which is TTL security in BGP, right? And that is my problem. If I tell you each and everything about the BGP, it has so many features that we are not going to complete this course even by 2023 November, right? But I want to make sure that if you take a document from the internet, maybe your customer says for a particular project that we want to have some more security in the neighborship. I do not want that neighbors who are after 2 can communicate with me over the BGP, right? Then basically you search for something and you found this TTL security. Believe me, if you read this on internet, maybe 2 or 3 or 5 lines, it is going to clear all of your doubt because now you have those fundamentals to understand the why behind TTL security. And that is why I mentioned when I was starting the class that although TTL security concept is pretty easy, I can tell you in 15-20 minutes, but believe me, there are so many features which I can't cover, right? But I promise you that, as I mentioned, that starting 15 to 20 or 20 to 25 kilometers, I will be with you in this journey, but the remaining journey you have to complete based on your project, based on your requirement, based on your interest too, right? So maybe this could be your assignment, that just try to have to find